Hey guys, welcome to another dynamics video. Today we're going to be doing a question where a box is dragged along the floor by some tension force. And the question is asking us, what contact force does the box apply onto the floor? So you can go ahead and pause the video and try to think through this question for yourself, and come back when you've finished. Okay, so the first thing to know about this question, and to know about dynamics really, is that the force that the box applies onto the floor is going to be equal and opposite to the force the floor applies onto the box. That's because of Newton's third law. So, if we can find out what force the floor applies onto the box, we'll be able to figure out the answer to this question. So first, let's look at all the forces on the block. So, you have the tension force to the right. You have the force of gravity downwards. You have the normal force from the floor upwards. So this normal force is going to be done by the floor. And you also have the force of friction from the floor to the left. So these two forces, the normal force and the force of friction, are going to be done by the floor. So if you can find out what's the total magnitude and direction of these two forces and you add them together, we'll be able to figure out the answer to our question. So, we know that the normal force is just going to be equal to the force of gravity, because the block doesn't go upwards or downwards. So, that's really easy to figure out. But, to find out how much the force of friction is, we need to figure out if this box is going to slide or if it's going to be static. And to do that, we need to see if this 100 newtons of force is enough to overcome the maximum friction force. So, the question is 100 greater than the maximum friction force, which is equal to the normal force times the coefficient of static friction. So is it greater than? We have to find out. So this is just going to be equal to 9.8 times 20, which is the normal force, times coefficient of static friction, which is 0.4, and that's equal to 78.4. So, the force to the right is going to be greater than the force to the left, and the block will slide, which means that there's going to be kinetic friction on the block. And kinetic friction is always equal to the normal force times UK. So, through this we can figure out what the magnitude of these two forces are. And I'll just draw them out so we can draw a triangle of the forces that are acting on the block by the floor, which remember are these two forces. And we're going to have the kinetic friction to the left, which I'll write as normal force times coefficient of kinetic friction, which is 0.35. And we also have the just normal force up, which is just 20 times 9.8. And the total force done by the floor onto the block will have this angle. So, using Pythagorean theorem, we can figure out that this side is equal to the square root of 20 times 9.8 squared plus 20 times 9.8 times 0.35 squared, which is equal to 208. And using trigonometry, we know that this angle is equal to tangent -1 of opposite over adjacent, which is 1 over 0.35, because these 20 times 9.8 will cancel out, which is equal to 71 degrees. Okay, so we know that the floor does a force on the box west 71 degrees up, and I'm going to assume that west is to the left. But the question asking us, what force is the box going to do to the floor? Which is going to have the same magnitude, but it's going to be in the opposite direction. So if the floor does a force west 71 degrees up, the box is going to do a force south 71 degrees down. So the box will do a 208 Newton force east, because the opposite of west is east, 71 degrees down. Okay? And that's our answer. And I hope you enjoyed the video and that this made sense to you. Thank you for watching.